Have you ever stopped to think about the tiny, silent engines that power our digital world? From the watch on your wrist to the traffic lights on your commute, even the timer on your microwave. There's this unsung hero working tirelessly behind the scenes. So today, let's pull back the curtain and uncover these secret timers that, believe it or not, kind of run our lives. Just think about your watch for a second. What's actually happening in there to make sure every single second is counted, perfectly without ever missing a beat? I promise you it's not magic, and it's definitely not some tiny person with a stopwatch. The real answer is something way more elegant, and it's totally fundamental to all digital electronics. The secret, it all comes down to the simple but incredibly powerful art of counting pulses. And the little component responsible for this is called a digital counter. That's the star of our show today. So what in the world is it? Well, a digital counter is basically a specialized circuit, and at its heart, it's really just a collection of tiny electronic switches called flip-flops. Its one and only job is to count electronic pulses. You can think of them like tiny, regular heartbeats inside a machine. How it works is actually beautiful in its simplicity. First, it receives a pulse. Second, it just adds one to its internal count. And third, once it hits a pre-programmed number, it resets back to zero and starts all over again. That's it. Receive, increment, reset. This simple little loop is the foundation for some amazingly complex systems.
Now, you should know there are a few different flavors of counters out there, but the one that's really important for our story today is the modulo counter. These guys are designed to count up to a specific number, like 10 or, say, 60, and then reset. And you're going to want to remember that mod 60 because it's about to become very important.
All right, let's get practical with our first case study and see how this little component literally builds the clock on your wrist. We're zooming right in to see how these counters create our experience of time. Everything, and I mean everything, starts with this number. Tucked away inside your watch, there's a tiny quartz crystal that vibrates at an incredibly precise frequency, exactly 32,768 times per second. This ridiculously consistent vibration is the master heartbeat of the whole system. So the big question is, how do we get from that super fast vibration to a useful 1-second tick? Well, a special circuit called a frequency divider takes those thousands and thousands of pulses and slows them way down, outputting just one perfect pulse every single second. And that single pulse is the fuel for our counters. And this is where the magic happens, the time-keeping cascade. That 1-second pulse feeds into a mod 60 counter for the seconds. Now, when that seconds counter hits 59 and resets, it sends a single pulse over to the minutes counter. And when the minutes counter hits 59 and resets, it sends a pulse to the hours counter. It's this beautiful, precise chain reaction. And what do you get from all this? The perfect system for a watch. It's incredibly accurate, all thanks to that stable crystal. It uses almost no power, which is exactly why a watch battery can last for years. And the whole design is compact, super reliable, and just simple. Okay, so we've just seen the counter working on a personal scale, right there on your wrist. But what happens when we take that exact same component and apply it to a massive public system? Let's zoom out from our wrist all the way to the roadway and see how this one tiny part goes from just measuring time to controlling a complex, life-saving sequence. Welcome to our second key study, conducting the traffic symphony. And I call it a symphony because that's really what's happening at a busy intersection. It's a carefully timed performance, and it's all conducted by our old friend, the digital counter. Now this is the key difference. In a traffic light, the counter's main job isn't just to track the passing seconds. No, it's to make sure that a specific sequence of events happens in the right order, for exactly the right amount of time. Public safety and order literally depend on it. So let's watch it in action. A clock pulse starts a counter that's set for, let's say, 40 seconds. For that entire duration, it sends a signal that activates the green light. And traffic flows. Easy enough? But once that 40-second counter is done, it resets and triggers the next counter in the sequence. This one is set for a much shorter time, maybe 5 seconds, and it activates the yellow light. Time to slow down. And after those 5 seconds are up, the final counter takes over, turning on the red light for its 30-second interval. Once it finishes, the entire cycle just resets, and the sequence begins all over again for the other direction of traffic. It's just a continuous, automated loop. The benefits of this are just massive. This system gives us total automation, which dramatically improves safety by preventing collisions. It creates efficiency by managing traffic flow and cutting down on congestion. And it's scalable. Modern systems can even link these counters with sensors for smart adaptive traffic control. It's brilliant. So, as we start to wrap things up, it's pretty clear that these digital counters really are the world's invisible timers. They're orchestrating everything from our personal schedules to our public safety. This table really brings it all home, doesn't it? We have two completely different applications, one for measuring time accurately, the other for managing traffic efficiently. They rely on slightly different principles. One is about counting pulses, the other is about sequencing events. But the shared hero, the core component of both systems, it's the exact same thing, the digital counter. I mean, it's just an incredible piece of engineering when you think about it. From the micro to the macro, from our own personal devices to huge public infrastructure, this simple little circuit is one of the essential building blocks that makes our modern digital world tick. So, the next time you glance at your watch or find yourself waiting at a red light, just take a moment and ask yourself, how many of these tiny, invisible conductors are running your life right at this very second, without you even knowing they're there?